My name is Alan Pickering, and I'd like to give you an update of the engine I made while in lockdown. Since then, I've found one or two little improvements I've made to it. Not only that, it gave me something else to do. The improvements I came across were to do with the water cooling. This is the cooling cylinder that cools the displacer, which is underneath here, and the water goes through this little jacket here, water displacement bit tube, and it goes into the main cooling tower, which is quite big. And I found that after about 2 hours you could only just hold your fingers in the water. The problem was the bottom of the tank was quite cold. As hot water rises, it was hottest in the middle where the water comes out of the cooling the displacer cylinder through this little channel, and it rises to the top of the cooling tower. But the water at the bottom remained pretty well cold, so I thought, this is not a very good idea. I can improve that with a water pump. So I made this water pump. It turned out to be an absolute pain to make, because I started off with a casting which I found, which was all shapes like a jigsaw puzzle, and was almost down to size before I could even start machining it, and it was ever so difficult to hold. I put a little valve in there as well, just to make sure that there was no airlocks and that it actually worked okay. There's also another little valve here which keeps the airlocks from forming. The eccentric. And while I was doing this, I decided to alter the linkage slightly, only really for cosmetic reasons. This top link here, you can see it, I've given it a bit of shape, and this is the old link, which I'll just put up there just to show you, one-handed. There we go, goes on there like so, to there, and if you notice, it's about 3/16 or a quarter too long, and it's these last two linkages here which were out. The ideal situation is to have this link here vertical when you were in top dead centre, and it wasn't, but it didn't seem to make any difference to it at all. But for the sake of purity and looks, I decided to do something about it. I also took a bit of metal out of these links here, just to give everything a bit more shape. It proved quite a difficult engine to build, as all hot air engines are, because they've got no power to speak of, and therefore there's got to be no friction whatever. That applies to water pumps as well. The pump is about 1/2 inch stroke with a 1/2 inch bore. The reason for that was that this axle here decides the stroke you can get, and I couldn't get more than 1/2 inch out of it, so I made up for that having a bigger ram. So while I'm thinking about it, let's get it going. It warms up pretty quickly, but the noisiest part of the thing is the burner. It's normally dead silent. Usually by about 15 seconds it's thinking about going. thinking about it, but I'm just. Have a walk around the engine. This is the pipe work. It moves the cold water from the bottom of the cooling tower up and round into the main cooling chamber. This works incredibly well because after 2 hours the bottom of the cylinder the bottom of the tower is the same temperature as the top of the tower, which is what I wanted. Not only that, it's something else to look at. There she is. Going like a good one now. The burners are a bit noisy, but fortunately once it's going you don't need too much gas. I'll turn that down a bit. Oh, it's not so bad now. That'll keep going like that forever. I've only had it running for about 2.5 hours, but it gives you the impression that it'll go on forever. It didn't reduce its efficiency by warming the water slightly. The water after that time is a little bit too hot to keep your fingers in the top. Yes, at present, you see, it's absolutely stone cold. For those who are seriously interested in making hot air engines, or in particular this one, it was published in Engineering in Miniature, which I'll just by chance happen to have a copy here on the bench. And there it is in all its glory. And if I can flick a page over, it is the October 2020 issue. There's about 5 pages, and for the keenies who are actually going to make one or have a go, which I encourage, I would suggest reading it because it saves you a lot of time and money and mistakes. It's not an easy engine to build, although it looks it. As the same with all these things, it's the alignments that are difficult, and you've got to have bearings in everything that moves. I mean, you see on YouTube plenty of hot air engines which are basically converted coke tins made with a knife and fork and coat hangers. But if you want them to be silent and look nice, then you've got to have bearings. Okay, they might be floppy and all over the place, coat hangers and coke tins, but at the end of the day it's going to sound a bit like 2 skeletons shagging on a tin roof. which isn't particularly a nice thing to witness. There she is, just ticking over nice and slowly, and it just so happens, purely by accident, that it needs to be in almost perfect balance, because whenever it stops, it always stops in a different place, which has got to be a good thing. Quite a hypnotic little engine, this. I made about 10 in the past, different ones, but this gives me as much pleasure as any of them. How smooth is that? This little valve here gets rid of any air pockets. There she goes, you see. And this one here makes sure that the pump is actually working, and you can drain it after use. There we go. Made rather a mess of things. Okay, so much for that. A quick walk round the workshop. So I'll keep all my junk and stuff behind the mill. Always in there looking for scrap. For anybody wanting to start a workshop, I would suggest the first thing you buy is a three-phase converter. That then opens the floodgates for lots of cheap machinery. This one down here, that is a spare three-phase converter, because nothing moves if that goes wrong. Just a little walk round while the engine's warming up. Unfortunately, I think the model engineering days are numbered, because when oldies disappear, I think model engineering will disappear. The youngsters don't want to know. All they want is throwaway plastic, smartphones, no time to learn how to create anything. Don't want to know. Couldn't learn to work a lathe if you give them £1,000. And not only that, they're not even interested. The same applies to the traditional jazz band that I did run for 20 years. No youngsters coming up. So it's a sad case. Very sad case, I think. Just for educational purposes, I'm just going around to show you my little empire, which I get great pleasure from being in. It's the only place on the planet that you really want to be in. Well, for me, that is. Everything you see on the walls I've made. I've made several of them. That's my Smart & Brown lathe. Tool room lathe. Excellent tool. Not expensive. what is important are all the tool quick Dixon tool post holders, tap and die holders, internal and external collets, bar collets, metric and imperial, boring bars and all sorts of turning tools. After 50 years it just builds up on you. Dehumidifier stops everything going rusty. These are all models that I've made in the past, all finished up on the front cover of the engineering magazines and even on Christie's catalogue, which is this one here, full-size ransom crawler. There are many more, but unfortunately they were all made before digital photography was invented. This is the Mitchell lathe, very cheap, £400 for a thing like that. Can't believe it, can you? Grinder, line coal inisher. Music. My jazz band sign, bandsaw welding machine, first engine I ever built, a King 4-cylinder. Okay, that's about it. Work my way back to the engine, see if it's still going round. These are all the junk boxes full of steel, various sorts, tapping machine, ultrasonic cleaner, bandsaw, slotting machine, polishing mops, another big drill, very useful because you can get all sorts of horrible ugly things under this drill because it moves in every direction. Might not be the most precise bit of engineering in the world, but the most useful. Brown and sharp, universal. Get nice big cutters on it, better than the average. Silver soldering bench. And there she is, flying away, using no gas at all. Quiet as a mouse. Let me turn it down a bit. It's far easier to make an engine, a hot air engine, go fast than it is to make one go slowly. To go slowly, it has to be absolutely perfect. The slightest little thing will stop it. For example, if I was just tighten this gland up, only a little, it would stop it. There's no piston rings in there. All these bits and pieces that you see moving up and down, they've all got ball races in. Okay, so that's about it. This is Alan Pickering signing off. Thank you everybody for watching.